All right, here we're dividing a monomial by a monomial. Basically what this is a quotient rule of exponents. So what you do is you're going to divide the coefficients in the front like normal. Sometimes they'll reduce, sometimes they won't. So looking at number 2, and you're only going to do the evens on this assignment. So looking at number 2, we have 4 and then 1 down here. So what is 4 divided by 1? And that is 4. Now I'm going to go ahead and write my answer as if I have a numerator and a denominator. Sometimes when you simplify all this out, all you will have is a numerator. So let's go ahead and look at now the a's, because those are the same base. When you have the same base, again, what we do with the exponents is we subtract it. So by quotient rules, we subtract the exponents of same base variables. So a to the 4 divided by a to the 1 is a to the 3rd power. Now here, when you subtract b to the 3 divided by b to the 3, 3 minus 3 is 0. And anything to the 0 power is 1. 2 divided by 2 is 1. So anything that's the same on the top as is on the bottom is 1. Now the reason why we subtract our exponents is because you're taking away. A to the 4 is a times a times a times a. On the bottom it has 1a. So 1 can cancel out because a divided by a is 1, leaving 3 a's on top in the numerator. Now looking at b to the 3rd power, we got b times b times b. Same thing goes with this case. B divided by b is 1, b divided by b is 1, b divided by b is 1. So this whole entire thing is equal to 1. So anything to the 0 power, b to the 3 minus 3, which is b to the 0, is equal to 1, and we don't have to put that there because 4 times 1 is 4. Now, and then you did a to the 4 minus 1, and that'll be a to the 3rd power. All right, so this right here, this monomial is going to be my my answer. All right, let's look at number 4. Now, number 4, 3 divided by 2 cannot be reduced any further. I don't have a u to divide with this u, and I don't have a v, another v to divide with this v, so this one's already simplified. I mean, because the only thing is that you're not supposed to have any negative exponents or any 0 exponents left over. All right, so let's look at number 6. 3/4 already reduced, so let's go ahead and add 3/4 to start off. Now, do I have an x? Nope. So x to the 4th stays at the bottom because I don't have another x to divide with it, but I have y's to divide here. So right here I have y to the 3 minus 4. Now, y to the 3 minus 4 is y to the negative 1. That tells you that that y is at the bottom. Because what we do with negative exponents is that we have to switch the position. So if it's in the numerator, it'll become in the denominator. If it's in the denominator, it'll move up to the numerator. Once you move it, that exponent, that negative exponent, will turn into a positive exponent. Now, if you think about it, I have 3 y's at the top and 4 y's at the bottom. So y times y times y, and then 4 y's at the bottom. And again, y divided by y is 1, y divided by y is 1, y divided by y is 1, leaving 1 at the bottom. So this is my answer. All right, let's look at number 8. 3/2, again, already reduced. I don't have a b to divide with this b, but I have the same a squared and a squared. So I have 2 a's on top, 2 a's on the bottom. Those will cancel each other out. Again, a to the 2 minus 2, if we follow the quotient rule by subtracting our exponents, and anything to the 0 power is 1. Again, anything right here, this same thing, it crosses out. So this right here is my answer. All right, number 10. Again, a squareds cancel out. I got 2 on the top, 2 on the bottom. If you do the quotient rule, it's going to be a to the 0, which gives me 1. And 4 times 1 is 4. 4b to the third power. And that's it. Because b doesn't have anything to divide with. Alright, now look at number 12. This is where it gets tricky. Because once you move something, once you move a variable, you might be joining another variable. That same variable up there. So this -2, I cannot have a negative exponent. So this is going to move up to the top. Then you're going to have m squared times m to the third power. When that m moves to the top, it's going to combine with this one up here. Because when you're multiplying your variables, you have to add these exponents. So this is going to be m to the fifth power over n to the fourth power. This is going to be something like on your quiz. That's going to show up on your quiz. Alright, 14. 4 divided by 3 is already simplified. So I can go ahead and just write 4 over 3. And then again, this one will join the x squared at the bottom, giving x to the fourth. And this one will join the y to the fourth at the bottom, giving y to the seventh. Number 16. 2/3 already simplified. You can't go any further. Now here, x will join this x down here, because no negative exponents, x to the fifth power. And this will come up here. Now anything to the 0 power is 1, but let's go ahead and just join this 0 and the negative and the positive 4, so that's going to be just y to the fourth power. Alright, let's go ahead and look at these right here. That's a 3, and that's a 4. Alright, 4 divided by 4 is 1. Okay, well I got n. So I have n to the 1 power over n to the fourth power. Now, again, 1 minus 4 is -3. So that means that I have 3 n to the third power on the bottom. Alright, let's look at my m's. I have m to the 0 over m to the third power. Again, 0 minus 3 is -3. And that means that m is on the bottom. M to the third power is on the bottom. And that's my answer. And again, we subtracted 1 minus 4 is -3. 0 minus 3 is -3. Alright, let's look at number 20. We got 2 divided by 2, which is 1. Now, this y is going to come up here, and so is the x. The x is going to go up there as well, because no negative exponents. So when you move the x, again, that exponent will turn into a positive. Here, you're going to move the y, turning the 2 to a positive, joining the 4, y to the sixth power. And that's how you, again, do quotient rule.